Robertson? We're going to say whether or not something is true, okay? Hey, our shirts, we're in the same color scheme there.
That is not it. Don't start that.
Color scheme. I'm not saying they're the same color. Calm yourself.
You what color is that, Mr. Possible? Is that just pink?
This is like salmon.
Salmon. Well, this is more salmon.
That's more of a salmon. Yeah.
This is more like freshwater salmon.
Yeah.
That's more like high-V salmon.
Nice. Okay, so this whole chapter though so far has been building up to proofs. Okay, so like I said, it's a formal or a structured way to go about and say, okay, hey, here is a way we can say something is true or false. We can say and go through. Here's why it's true. We can say it's true. Then we can say why is it true? Because when you go out in the real world, or when you go and argue with your parents or your siblings or teachers, whatever it is, okay, you're not just going to be able to say, oh, this is true, and then just get your way. You have to explain why it's true. You have to prove why you're right. Okay? A lot of times you have to prove why you're right for people to believe you, right? They aren't just going to take your word for it. You have to prove it. And so this is a formal way to go about that in math, but it can be applied to other things as well, okay? And now, this idea of proof is a new idea. So we're not going to start off this new idea and throw in geometry stuff right away, because that's two new things at once. I've talked about that a lot in this chapter, and that's confusing, okay? So we're going to start off with new stuff with algebra. So we're going to prove algebraic equations. We know how to do algebra equations. We did that last year in Algebra 1, right? So now we're going to go through and we're going to talk about our properties of equality to refresh. Because these are things that we know are true. Okay, these properties we know are true. They're universally accepted. And so if we can all agree upon, oh, that this is true, then we can use these as arguments to get to our final point. Because if you agree with the individual arguments, then you're probably going to agree with our final point. Okay? Hey, girls, be good. Okay, Mr. House and walk in the seat. So I just want to make sure. All right. So we have our addition property of equality. So what this says is if some number A is equal to some number B, any two numbers, but don't care what they are, as long as they're equal, okay, then if you add the same thing to both sides, in this case, some number C, it's still true. Okay? So like a real world, like a real number example of that is like if you have 3 is equal to 3, and we have the same thing to both sides. Kayla, what do you want to add to both sides? Awesome. So we have 2 to both sides. Well, is that still a true equation? Yeah. So if we start with a true equation, whatever the equation is, if we start with a true equation, and we add the same thing to both sides, it's still true. And we know that from Algebra 1. We know that to be the case. Yeah, it's not new to us. Then we have our subtraction property of equality, which is the same thing, but with what operation? Subtraction, right? So if A is equal to B, then A minus a number is equal to B minus that same number. So if we do that in numbers again, okay, let's say we start off with 3 equals 3 again. Let's just start with the same place. James, give me a number.
21.
Okay, so we'll do 3 minus 21. Is that going to be the same as 3 minus 21? Yeah, because we took this equation, 3 equals 3, and we subtracted the same number from both sides, okay? And would it matter what number James picked? No, okay? It would have been, this, as long as we subtract the same thing from both sides, we're okay. We do this to solve our algebra equations all the time, okay? Multiplication, same thing, but with what property? Multiplication, okay? I should have said what operation. So if we have a true equation, A equals B, then A times C will be equal to B times that same C. Okay, so go through, we'll still say 3 equals 3. Okay, Sarah, give me a number that we're going to multiply with.
4.
Okay, so we're going to do 3 times 4 is equal to 3 times 4. Is that still true? Does 3 times 4 equal 3 times 4? Yeah, because 12 would be equal to 12. Cool beans. Okay, division property of equality. Okay, bless you must reigns on half, lest we forget. Bless you must reigns on half, lest we forget. Okay, so if we have a true equation, A equals B, and what operation are we going to do this time? Divide. Okay, so if we have A divided by C, that's going to be equal to B divided by C. As long as C is not what number? What number can't we divide by?
0.
0, right? So as long as C is not equal to 0, we have to make that little distinction there with division. You can multiply by 0, subtract by 0, add by 0. That's all fine. When we divide by 0, that breaks math, and we say, I don't like it. So if I have 3 equals 3, and then we take 3 divided by the same number on both sides, Taylor, what number do you want to divide by?
9.
Okay, awesome. So 3 divided by 9 is going to be the same thing as 3 divided by 9. Okay? This is both 1/3. Equal 0.3 repeating if you want. Okay? Those are not new, okay? Those are Algebra 1 fundamentals. Okay? We're going to continue on right below this, and we see, hey, distributive property. If A is multiplied with the quantity of B plus C, or the sum of B and C, then A times B plus C is the same thing as A times B plus what? A times B plus A times C. Our distributive property, right? But if it's outside the parentheses, it's being multiplied with the whole parentheses, we distribute it in and multiply it to each individual thing. Okay? Then we have our substitution property, okay? We just call this substitute, or a lot of times our slang in math is to plug it in, okay? So in this case, if A is equal to B, then A may be substituted or put in place of by B in any expression or equation. So we're saying if two things are equal, then we can replace them whenever we want because they're the same. So that's like we have like x equals 4, and then we plug 4 in back into the equation. That's using substitution. That's using the substitution property. Okay? And these properties, you might not have talked about this before, but we do actually know these to be true just because of operations we've done, even if, like I said, we haven't actually called them these properties. So we have reflexive property. For any number A is equal to A. Is something always equal to itself?
Yes.
Yeah. Is my height equal to my height? Yeah. Okay. 5 is equal to 5, right? Okay. Then we have our symmetric property. If A is equal to B, then B is equal to A. We can flip it around. And we knew we could flip equations around, right? We talked about that before. We knew we could flip it around the equal sign. Now we just have a property that's actually saying we can. Okay? That's just saying it's symmetrical. Remember on that quiz we had, we were talking about capital letters being symmetrical. It was kind of like flipped over the one side. I kind of missed my dashes there. It's kind of flipped over the one side. Well, that's the same thing here. A, B, now we flip it, A to B. Then we have our transitive property saying, hey, if A is equal to B and B is equal to a third number C, what's something we can know from this? A is equal to C. If A is equal to B and B is equal to C, well, we can say, well, A has to be equal to C then. Questions on that? Okay, we could also go through that saying like, hey, this isn't true, but let's say if I'm the same height as James, and James is the same height as Peyton, am I the same height as Peyton? Yeah, I would be. Okay. Let's continue on right below this. Okay.
Everything I say.
What?
Everything I say was
I don't know how it started. I don't know why it's you. It just happened. Let us roll with it. Okay, now we're going to practice using these properties of quality. So we can use these to justify, or that's our argument, okay, steps in solving an equation. So this is this two-column proof idea we're talking about. There's multiple ways to do proofs. A two-column one is the most structured way, and so it's typically the easiest one to learn because of how structured it is. Right, Maggie?
Right.
Okay. So this two-column proof, it's new, okay, shiny, okay? It's a common format used to organize a proof. So the left side of the column of the proof, there's a left side and a right side. This is 1, 2 columns. Okay. The left side is where we list our statements. Okay. And that'd be like your points in an argument, or in this case, it's our steps in solving. And the right side lists the reasons that justify each step. That'd be like our explanation in an argument. Okay, you make your point, you explain. We make our statement, our step, and then we justify how we're able to do that. Okay? So we have 4 different main things that can be used as reasons. So we have properties, like our properties of equality we just learned, or just reviewed. Definitions, There's a set definition that's agreed upon. We kind of like using the dictionary and say, hey, well, this word means this, okay? Postulates, if we recall back to one of the first days, talking about the building blocks of geometry, postulate was something we accepted to be true. Okay? That was like our segment addition postulate. You can add 2 parts of a segment to get a whole segment. Okay? And then theorems, which are things we can prove to be true from these other things. But a theorem's already been proven true, so we can use it. So we said, oh, that's already true. It's not like a theory where it's like, oh, this might be true. A theorem has already been proven true. So anytime in a proof, we'll be given something. We have to have a starting point. And then we're going to be trying to prove something here. So here we're given this equation, 4x minus 1 equals 27. So that would go in our first step on our statement side, on our left side here. Because that's our first statement. That's like our opening argument. Hey, we're starting 4x minus 1 equals 27. And then if we fast forward a little bit, our last one will always be what we're trying to end up with. Because once you get to your closing argument, you're done. Once you get to what we're trying to prove, well, we're done. We already got there. You don't need to prove something and then keep going. That's just how you make people annoyed, right? Like when somebody's like arguing with you, or like your parents give you a reason and you say like okay, and then they keep going, that's when you get annoyed, right? Okay? So you don't want to prove something and then keep going. Okay? That's just when you make people angry. Okay? And then everything in the middle, in this case, only one other step, okay, but sometimes there's multiple, okay, is just steps to get there. So 4x minus 1 is equal to 27. Well, how do we know that's true? We were given it. So our first step is going to be, hey, this was given. Here's the thing, guys. Every single time, the first reason will be given. Every single time. Okay. The second one, 4x equals 28. How did we go from 4x minus 1 equals 27 to 4x equals 28? What math did we do? We added 1 to both sides, right? Okay, you added 1 to both sides, okay? So what property tells us that we can add the same number to both sides of an equation and it's okay? The addition property of equality, right? Okay? And so I'd be okay with us even just saying, hey, we can call that addition. I'd be okay with us saying, hey, we can even just call that addition, okay? But yeah, we know it's our addition property of equality, right? That's saying, hey, we can add the same thing to both sides. That's going to be the same thing. Actually, let's call it the addition property, okay? Yeah, I'm okay with us dropping the equality, and we can just shorten it to prop there, okay? Or we can shorten it to add prop if you wanted, okay? I think we would know what we're saying there. If that's confusing you, write the whole thing out. Okay? If the shortcuts, if the abbreviation is confusing, write it out. Okay? So we're saying, how did we go from our given to this step? How did we get here? We use the addition property. That says we can add 1 to both sides. And so even though it doesn't actually list that plus 1 there, we can see the word behind it because we know what we're doing. So then what math would we do to go from 4x equals 28 to x over x is equal to 7? You divide by 4. So what property is that? The division property. And so I'd be okay with the div prop, okay? Saying division property. Now if you're actually telling this to somebody though, if you're saying this out loud, I don't want you to read div prop, I want you to read division property, okay? If we're going to read it, we're going to read division property, okay? Yes? What was that?
Why would you just put
Oh! Okay, so you're saying like here we put given, here we put prove, okay? Because we still have to say how did we get to this step. So that's so I love that question, okay? So we're saying how did we get to the first step? Well, the only reason we're able to get here is because we were given this. Here though, we got to this because we divided. That was the math we did to get there. So we don't just put prove because prove isn't how we got there. Proving is just what we're trying to do. Does that make sense? It's a great question though. Okay, any other questions on this first process, this first 2 columns? Thank you, lady, guys. Okay. Hey, let's go ahead and flip the page here. Okay. So now we're given a different equation. A divided by -6 plus 2 equals 5. So that goes in our first step here. Our first statement is what we're given. And we're trying to prove A is equal to negative 18. So that's going to go at the end. In between is the step it takes to get there. So the first statement, we don't know this unless we're given it. We're not just going to come up with some random equation. We don't know this unless we're given it. So we were given that. Then, how do we go from step 1 to step 2? How do we get here? What changed? We subtracted 2 to both sides, right? This got subtracted by 2, it's not there anymore, it became 0. And 5 got subtracted by 2 to get to 3. So what says that we can subtract the same thing on both sides of the equation? The subtraction property. And now I'm going to put SUBT, okay? Because if I put SUB, there's 2 different number of properties that start with SUB. The substitution starts with that too. Okay? So if I don't put that T there, we might not know whether we're talking about substitution or subtraction. Okay? We're gonna put the T on there, okay? Otherwise let's not even abbreviate it, okay? So if we're gonna abbreviate it, we need to make sure it's clear abbreviations. So then, how do we go about getting from being divided by negative 6 equals to 3 to normal A is equal to negative 18, Riley?
You multiply both sides by -6.
Yeah.
Or 6.
Yeah, you multiply both sides by negative 6 there. And so that's our multiplication property. So our multiplication property says we can do that. Questions on that? Okay. Let's try number 3. Okay. So we're given another equation here. Negative 9 times 2x minus 3 is equal to 63. And now we're trying to prove that x is equal to negative 2. So our first statement is going to be what we're given, because we have to have a starting point. So we're given this. And we say, hey, it's given to us. From here, what math did we do to alter this? We distributed, right? We can call it the distributive property. Very good. We distributed to get there. Okay? I'm going to ask you guys to finish off these last 2 steps. Once you have them or have questions, I want you to raise your hand, okay? Once you have these last 2 steps or have questions, I want you to raise your hand. Thank you. Okay, I'll check.
Sure.
That'd be nice.
Is the rest of it right? Are you sure it's in division?
How do we go from here to here?
No, I'm not.
From here to here? Distribution. Distributive.
I thought
Does that
this
make
was
sense? Okay. I understand your question. Yeah. Okay. Okay, let's go ahead and talk about this one up here. Okay. So from set 2 to 3, from what I saw, okay, we did our subtraction property call. We subtracted 27 from both sides of the equation. Then from there to get to negative 18x equal to 36, I saw that we divided, or those that I checked and those that other people checked had that we divided that would be using our division property of equality there. Okay, our division property. Okay, questions on that one? Okay, so reminder, our first one's always going to be given because we have to start somewhere. We have to have something given to us to know where to start. Okay, I want you guys to try number 4 on your own. I want you guys to try number 4 on your own. Okay, once you have it or have questions, I want you to raise your hand on number 4. Very good.
What is that? That's dumb. I don't even know how to spell symmetric.
Oh, can you look back at the previous page?
Where? Where do you see these words? Oh.
Thank you, Joseph.
Oh. How do you go from there to that?
Okay, bless you, let's raise that after I forget. Hey, let's go ahead and talk about this one up here. Okay, so our first step is we're subtracting what from both sides? 6x, so that's our subtraction property of equality, okay? Okay, talk about it briefly. You might be wanting to call it combined like terms because we see 6x and 8x, we say, oh, those are like terms, okay? So this one actually would still be subtraction property of equality. We'll save combined like terms for another example, and we'll see when we use it. So I'll kind of explain the difference then when we actually see it. It's more real. Oh, okay. So then from here, we add 17 to both sides. So that was what property, Betsy? What property was adding something to both sides of the equation? Addition property. Okay. So then we divide both sides, and we got what, Rowan? Division property of equality. Wow. Okay. Then what was our last step there? Our last step there, Sarah? The symmetric property of equality. Very good. Okay, the symmetric property. Saying, hey, we can flip the equation. That's perfectly fine. We can flip the equation, okay? And that's just because they specifically said, oh, x plus equal 12, not 12 equals x. Even though we know it's the same thing, that's our actual step to get it there. Okay? Questions on number 4. Okay? Let's look at number 5 together.
We should try it by ourselves to see if we understand.
There's a new step in there that we won't know.
Bet.
Okay. I'm not a betting man. Okay? So we're given our statement first. And our proof, x equals 2/3, is going at the very bottom of our statement. So once again, once you get to where you prove, you're not going to keep arguing. Okay? So what's our first step here mathematically that we do? Distribute. So we're going to write on reason 2. Distributive property. Distributive property is what we're writing. Okay? Then, this is our new step. What do we do here? Combine like terms. Okay, we combine negative 7x and 4x and got negative 3x. The reason this is combined like terms and reason 2 on number 4 was not is because here 6x and 8x were on different sides of the equal sign. So we had to subtract it to get it there. That's using our subtraction property of equality. From here, though, from step 2 to 3, in our reason 3, these negative 7x and 4x are on the same side of the equal sign. So we can call it combined like terms, which I'm okay with saying CLT, okay? And you might also want to just call it, which I'm also okay with, this is a slash thing, I'm also okay with this. I'm also okay with calling it simplifying. Combine like terms slash simplify. I'm perfectly fine with you calling it that. Okay? Either one of those two would be acceptable. Okay? I think we most common say combine like terms. Okay, that's CLT, combine like terms. Okay? If you guys want to finish this one out from here, you guys can. Okay, you want to finish this out one from here then. And once you have it, raise your hand. Okay? questions or anything else.
Why not? She's still.
I know where I am. This right there.
Don't do it, don't do it.
Well, it's not me, so obviously it's not
Wait, you look at my screen. They look good. It's so cute.
Johnson heard it from all of Don't touch my bell.
No.
Alright, we're gonna go ahead and talk about this one up here. Okay? So, step 4 here. Step 4, okay, negative 15x minus 14 is negative 24. Hey, actually, Kev, you want to lead this one?
Number 4 be subtraction because you're taking 12 and minusing it both sides.
That's what we're doing.
Good job, Kevin. I'm proud of you.
Thank you. And then the next one would be addition because you're adding the negative, no, you're adding 14 to negative 24. So I get negative 15x equals negative 10. And then the last one would be division because you're taking 15 and dividing from both sides.
Good job, Kevin. I'm proud of you.
I'm nervous.
Hi, nervous. I'm Mr. Dawson.
Awesome. I have a question. Why does there 4 boxes and you only need 3?
Are you talking about a future one? Yeah. Hold up. Hey, so. Hey, I slap on the back, Kevin. Great job there. Okay, kind of threw you into the fire there, but you did great with it. Okay. There's only one slight thing I would alter, and it's just a spelling thing. What thing would I alter? Does anyone know?
T. I have a T.
I'd add a T on subtraction on the sub, because otherwise you don't know if it's substitution or subtraction. Okay. So I would just clarify that. That's the only thing I would alter. Everything else was great. Okay. Any question on that one? Okay. What?
Just like you guys feel it too.
Okay, never mind. So
What'd you say?
You like left-handed people that make you weird.
I know what you're talking about.
I'm not
Just like, because I'm handed to like, give them the wrong thing.
I probably make less
What's their wrist?
Let's go and flip the page.
No.
Okay. Hey, what's different here?
You have to write your own statement.
We have to write our own statements now before they were given to us. Okay. We have 8 different ones here. We're not going to do 8 different ones. Okay. We have 8 different ones. We're not going to do 8 different ones. Okay. Has up on that, just so you know mentally that we're not going to do all 8 of these. So don't be like, we have to do 8. Okay, no. Okay. What's going to be our first statement here? Raise your hand if you can tell me our first statement. Okay, Jocelyn.
3x
Very good. 3x plus 1 equals negative 14. I'm going to put a 1 saying that's our first statement. How did you know that was our first statement? It's our given. Okay? Here, Carly, we need to give our first reason too. So what is that?
You're asking me?
Yeah. Okay? Someone help. Someone else want to? Riley.
Given.
It's our given. Okay?
I'm so smart.
Yes, you are, Riley. Yes, you are. Okay? Hey, so 3x plus 1 equals negative 14, and that is given. Okay? Our first step will always be, our first statement or step will always be what's given, and our reason is that it was given to us. Okay? So then we move on from there. So now, what math would we do, guys?
Subtraction.
Subtract 1 from both sides. So if we subtract 1 from this side, do we still have a 1 here?
No.
No, so we're down to 3x. If we subtract 1 from the right side, what do we get? Negative
31. Negative 15.
15. A negative becoming more negative. And what tells us that we can subtract 1 from both sides? The subtraction property tells us we can do that and it's still equal. So that's our reason now. Okay?
Oh.
And our third step
X equals negative 5.
is saying x equal to negative 5. And how did we get to that?
negative
By our division property.
Oh, I got it.
Okay. And I'll go through and I'll explain this in a second here, okay? Hey, we didn't use all the boxes, but did we get to what we're trying to prove?
Yeah.
So we're going to go ahead and stop, okay? Mr. Collins, why does this one have 4 boxes when we only need 3, okay? Typo, sometimes it happens, okay? Okay? A lot of times, I'm nice with these and I give boxes and whatnot, but a lot of times you have to like draw on your own and do it, okay? But I decided to give it to you, okay? So sometimes they're off on the numbers, okay? Hey, pro tip, okay? If you're not sure what step to do, write this equation off to the side somewhere or on a scratch piece of paper and just walk through solving that like you do in algebra, okay? Say, okay, I subtract by 1, 3x equal to negative 15, and I divide by 3, x equal to negative 5, okay? If this part of it is what's tough for you, please write this off to the side, okay? Because then you can walk through and say, okay, how did I get here? I subtracted. You see the subtraction happening. How did I get here? Oh, I divided. You see the division happening there, okay? So that's a tip you can do off to the side. There's no room to do it on scratch paper. Yes, Kevin?
Good. Like for the step 4 instead of crossing average, but negative 5 equals x. So like symmetric property.
If you wanted to, yeah, you could. You could. We are just trying to prove that x is equal to negative 5, but if you wanted to, you could. Yeah, that's a great question. Okay? Any other questions on this one? Okay. I want you guys to see if you can try. I want you guys to see if you can try number 2 on your own.
Okay.
Okay? Once you have it or have questions, I want you to raise that hand. Once you have it or have questions, I want you to raise your hand.
Okay.
Oh, man.
Oh my god, too much coffee.
How do you do that so fast? That'd be really long.
Isn't it crazy that your brain just like does math?
Yes.
Like it's almost like walking.
But just in case we don't think it's
That's how it is to me.
but that's very good.
Like what's 2 plus 4 and 6 and just like walking, you know? Like you don't think about walking, you think about adding things. I know.
Yes.
Mr. Halverson probably just thinks you have an awful class just because he
I mean, you're probably the worst student ever, so.
probably. I am a problem child.
That problem.
Thanks.
Yeah. Good luck.
I just had to do it.
I like it. I appreciate it. You make me feel less weird by doing it now all the time.
I'm not like that person.
Hey, you and me both. Very good.
That's you have to.
So when you finish your tree. Yeah, Jeff.
Freak out box.
And we're gonna talk about this one up here, okay? We're gonna talk about this one up here.
I was right.
Yes, you're very.
Oh.
Let's practice that again. I wanna walk back. There we go. That's the proper way to do it, right? Okay. Hey, raise your hand if you want to come up here and do this one. Hey, Justin, go ahead.
I had it all planned out.
You want to put your phone away though.
Yeah, I was just trying to set my background like.
It doesn't seem very priority right now.
I'm trying his best. I wasn't lucky. It was just like the fact about. That looks like Gavin. Was that here?
That makes sense when it's felt like that though. Because like the
Okay, but let's not do that. Makes me feel uncomfortable.
Hey, can you make Mr. Castle? Is your flag back like inside out? Why is the tag on that side?
I don't know actually. I'm gonna tell you what that's like.
It's definitely inside out.
No, the union. That's what the Starfield's called. Okay, the union. Okay, it's supposed to be on the top left corner.
I know.
This is right because on. Oh wait, no, it's not. Wait.
No. Guys, you can't flip the flag around.
You can't. Yeah, you're not. You can't. But like,
I
I
know,
don't
but,
understand
like,
that.
They should put this on the back so that it
Yeah.
gets rid of my OC.
But like,
You should not like that up. That's good. I cut it off.
If you hang that one downwards, then that'll be okay. Yeah. Because
If you
can
hang it-
hang downwards.
what's the? Oh wait, that's the cross. I was like, if you want to get upside down, it's like.
It's like on that flag, for example, the Starfield field with top left. You know, it's on the
Why don't you just chop it off?
Yeah, why don't you just take scissors to it?
Oh, they went like a flag. That's why I gave you that look.
No, I'm saying chop this a little bit.
I guess I could.
I should get you
Can I
a
do
flagpole. Can we get a flagpole in here? No, like, you know what I'm talking about?
Like a mini flag.
No, like not like the ones outside. Like the ones in the rod saver. You know what I'm talking about? What up, are those the same height?
Not right now.
Let's figure it out.
Okay, Justin, explain what you did, please, and thank you. Yes.
Wait, is this the only?
Oh, you fixed it.
Yeah, I fixed it.
Really?
Then like, we're just gonna review properties.
Okay.
Okay, so you start out by distributing 2 to x and then 9, which gives you 2x minus 18. All that equals 10, negative 10. And then you add 18 to both sides, which gives you 2x equals 8. And then you divide by 2, which gives you x equals 4.
Very good, very good. Okay.
Good job.
In Espanol, okay.
No.
Dos x. X in Espanol, ¿cómo se dice x?
Well, what's the vowel? It's
¿Cómo se dice x en Espanol?
there's
I
no
have
one
one.
understanding.
I don't know.
Someone
say anyone's name?
I think X is honestly just pronounced as X.
X?
Hold on, wait.
¿Cómo se dice X?
Aquis? Okay.
No,
Dos aquis menos 10, no,
28.
18.
28.
18, okay.
Wait, no,
S-
that's
S-
DSA
It's
Ocho.
doce
It's
ocho.
DSA.
DSA 8.
18.
Yes.
Okay, so
DSA Ocho.
dos aquis menos 18 es igual negativo 10. Okay. Dos aquis, okay, S equal ocho. Then X no, X S equal us ocho. I had a student challenge me to do a problem in Spanish last class. I'm trying to get, did not work out very smoothly. Okay, we're gonna skip number 3.
Okay, go.
Okay, we're gonna skip number 4. Okay,
Oh.
let's flip the page. Okay, and we're actually gonna skip number 5. Oh, okay.
Wow.
And we're gonna go all the way down to number 6. Okay, 5n minus 4/2 is equal to 12n. We're gonna go through this one together. Okay, so our first statement is always going to be our given statement, right? So 5n minus 42 is equal to 12n. Caleb, what's our justification for that? It's given. I couldn't agree more, okay? That would be our reasoning, our justification, our argument for that, okay? Our second step, okay? Hey, what math would we do here? And if we need to, we can write this below off the side as well, okay? You would subtract 5n, okay? So we'd be left with negative 42 is equal to what kind of n? 7n. And what property tells us that we can do that, James? Subtraction property. Very good. Okay. Then on step 3, what math would we do?
Divide.
Divide by 7. What's negative 42 divided by 7? Negative 6. What's 7n divided by 7? Just n. And what property tells us we can divide both sides of the equation by the same number? Division property. Okay. So hey, now did we have exactly what we have up here?
No.
Okay? No. I'm going to put a little asterisk next to this last step. And there's a reason why I'm putting an asterisk next to this last step is because I would say I am okay with you leaving it either like this or in this answer. I'm okay with either one. Okay? I'm okay with either one. Because you can leave it like this because negative 6 equals an n. I'm okay with leaving it like that because some of these problems, depending on how we solve it, you'll run out of room on your boxes, okay? So what would be our other one though? What would be our step 4 then?
N equals negative 6.
N equals negative 6, and that's our symmetric property. That allows us to do that, okay? But if you got down to negative 6 equals n, I would be okay with that as well, okay? Because sometimes how we go about solving it, okay, we end up with only, we end up at the bottom, and we end up as negative 6 equals n, and we ran out of room. I don't want to have you guys add on to a table or question whether you're wrong or right, okay? So if you get down to that, you're Gucci, okay? Now should we have already known that we were going to get negative 6 as our answer?
Yes.
Yeah, because we're told that. Yeah, that's what we're trying to prove. Okay, questions on that? Okay, we're actually going to skip 7 and 8 as well. We're going to go on to the next page, okay? I don't want to cross that out in case Mr. Costa uses that as a warm-up, okay? But just heads up. But we can also do that on a separate piece of paper. We're going to name the property that we use, okay? We're going to practice these properties a little bit more, okay? So we're going to match. You will use answers more than once, more than likely, okay? There's more options for numbers than there are options for our properties of equality that we're talking about here. Okay, if k equals 3, then 3 equals k. So what happened in our hypothesis to our conclusion, our if and then what happened between here and here? They switched. What property says we can flip around? The symmetrical property, that is h. Okay. Number 2, if 2x is equal to 14, x equals 7, what happened from here to here? The division property of equality, letter D, or de in Espanol. Okay? Okay? What I'm going to have you guys do, okay, I want you two to work on 3, you two to work on 4, you two to work on 5, 6, 7, 8, 9, 10, 11.
Wait, what are we working on? What number are we doing?
What number were you guys doing? Okay, you guys are 7. After you do it, talk with your partner and confirm. Once you're done, high five your partner. Once you're done, high five your partner. Once you're done, high five your partner. Oh,
You missed it.
sorry. And I hooped.
Guys, I'm gonna be in frat boys.
Weird.
No.
Okay. Number 3, what did you guys get? Reflexive property G. 4 is equal to itself. Okay. Number 4, what did you guys get? A. Addition property. You add 1 to both sides. Okay. Number 5. 10A is equal to B. 2B and 2B is equal to C. Then 10A is equal to C. What did you guys get? I. The transitive property. I know we didn't practice that one, but it would be the transitive property. Okay. We didn't practice reflexive either. We got that one. Good job. Okay. Justin and Betsy, what did you guys get for number 6? E, the distributive property. Very good. Okay. Number 7, what did you guys get? What did you get, ladies? Get? Said what?
B.
B, I agree. Okay. That would in fact be our subtraction property. You subtract 3 to both sides, right? Okay. Even though we didn't actually finish the subtraction, that's what we did. Okay. Questions on those first 7. Okay. So now we're going on to numero 8. Okay. Which is what? F. That would be FA. Okay. That would be our substitution, saying, hey, if W equals 1, we can plug in that 1 for the W in the equation. Everything else is the same. That 1 changed. Okay. Number 9. 9.
We don't know.
Don't know. Okay. What's your guess? C. Okay. I'm going to agree it is C. If y equals 2, y over 2 is equal to negative 10, then y equals negative 20. What happened on the left side to get to just y? Multiplied by 2. What happened to negative 10 to get to negative 20? Multiplied by 2. So we multiplied both sides of the equation by the same thing. Does that make more sense? Okay, awesome. Okay, number 10. I. Okay, I agree with that. That would be our transitive again. 3x equals 2i, 2i equals e. So the first equals the third there. Okay, and number 11. It would be A. Very good. That would be our addition property. We add 4 to both sides of the equation. Okay. Here's what we're gonna do. Okay, I'm gonna have you guys. We're going to go over 12 through 16 together here. Negative 2x equal to 18. 18 is equal to negative 2x. What did we do? We flipped it. We did H, the symmetric property. 13, 3x squared plus 1. And then if x equals 5, then we put 5 in there. What property is saying we can put 5 in there for x? Substitution property, letter F. Then we can substitute 5 in place of that. Okay. Number 14, m equals negative 2. Now we have 8m is equal to negative 16. That's multiplication property. We multiply both sides by 8. Okay. 10y is equal to 10y. Same thing is equal to itself. What is that? Reflexive. Okay, that would be G. Okay. And then 16, last but not least, 5x plus 8x is equal to x plus 5 plus 8. Okay. And this one's a little weird, but it is a distributive property. Okay. It's kind of backwards though, isn't it? Yeah, it's really kind of backwards there. Okay. Questions on that? Okay. You can put these notes away. Okay, it might be a helpful tool for later. Okay, we'll put them away for now. Okay, we have a nice hot pink worksheet here for us, okay? Okay, so this is more practice, okay? This is practice over what we just did. I felt like today you guys had a pretty good grip on it in class. This is an opportunity to show you have a pretty good grip on it outside in class as well, okay? And not just doing it together, okay? On numbers 1 through 9, okay? We're matching just like we did at the end there. Whereas on 10 through 14, okay, we're doing those two-column proofs like we did for the rest of the section there, okay? And these are the ones where you have to fill in the statements and the reasons yourself, like those last few we did, okay? On these, once again, you might not use every line, but you more than likely will, okay? Questions on this? Today's lesson didn't make sense. What do you guys do? Watch the video, come in for help, ask a friend, okay? Lots of different options, right? Okay, cool beans. Okay, we have a few minutes to work here, so I wouldn't suggest putting in music yet, just because it's only a few minutes here. But go ahead and begin work, okay? And I will play a song.
Like 1 through 9.
Yes. 1 through 9, I actually, let me double check that, okay? Numbers 1 through 9, there are no repeats.